Here, a 1.019 kilogram block slides along a rough ground by means of a rope, pulling it under a tension of 2 newtons. Okay, so that is 1.019 kilograms, and what is the acceleration of the block? And here, this is 2 newtons. There's a reaction force here. There's a weight here, and this will be 1.019 G. And there's a friction force here. And in this question, I tell you that the friction force is 1/10 of the reaction force. So this is 1/10 of whatever R is. And this is actually kind of the usual situation in physics anyways, that the friction force is actually something that depends on how strong the reaction force is. Anyways, what is the acceleration of the block? So it will accelerate horizontally because it slides along the ground, so there's no vertical motion here. So you have R equals 1.019 G, which will equal 1 Newton. So that means 1/10 of R is 1/10 of a Newton, or 0.1 newtons. So in total, there's 2 minus 0.1, so there's 1.9 newtons of force net. So from Newton's second law, N2, F equals ma, we get 1.9 equals 1.019 A, so A is 1.9 over 1.019. 1.9 divided by 1.019, 1.86. .865 we'll say, meters per second squared. That's part A. What is the acceleration of the block? 1.865. Now part B is what's the acceleration of the block if it's at an angle of 20 degrees. So let's just make the changes here on this diagram. If it's at an angle of 20, then the 2 would be here. So this would then be 2 cos 20, and this one here would be 2 sine 20. So the difference here is that it will be R plus 2 sine 20. This plus this equals that. So the R will be 1 Newton minus 2 sine 20. Let's see what that is. So that is 0.316. And the friction would be 1/10 of R, which would be 0.316 divided by 10 now, which will be 0.0316, I think. Yeah. Okay, so now that changes the situation here, because the total net force will be 1.9. Will be 2 minus that previous answer. So 2 minus answer. So that is 1.684 instead. So less force horizontally here. So that is the F divided by the M, which give me the A. And now it's only 1.65 instead. Less, which makes sense because he's pulling at an angle now. Okay, so that's 1.653. And then finally here, let's see, at what angle will the rope no longer cause the block to accelerate? So at what angle can we put this at so that the block no longer accelerates? So maybe just redraw that here. So what we're looking for is that this is a Newton. This is the friction, which is 1/10 of R. And then this component here and this component here, this one is 2, we'll call this angle here theta. So this one here is 2 sine theta, and this one here is 2 cos theta. And for it not to accelerate, it means all the forces must balance out. So we have r plus 2 sine theta must equal 1, and 2 cos theta must equal a tenth r. And we're looking for theta. So r, if I take that, I can say r must equal 20 cos theta, and I can put that in here, and I get 20 cos theta plus 2 sine theta must equal 1 then. Now this is a little bit tricky to solve. I didn't realize it would be this tricky to solve, so I wonder if there's some other way I can be looking at it. I mean, a couple of things I could do, but I don't know if it would necessarily make it any easier. That would be that. No. Okay, I made this question harder than I thought. Okay, well, I don't know if I've made this too hard and I should delete it. What I'll do, okay, so later in the course for sure we should be able to solve this, and there's a couple of ways you could solve this. You could square both sides, and no, that doesn't really work here. Okay, actually, come to think of it, the method to solve this we won't actually see until semester 2. So I'll have to change the question a little bit here. We will use our calculator to try and solve this. That's how I'll change it for semester 1. Semester 2, we should be able to solve it. Semester 1, I'm not expecting you to. So let's just have a look at the calculator here. Okay, so we have this mode on the calculator called table mode. So we'll type in 20 cos the variable plus 2 sine the variable, and we'll make a table of all different values of theta. So theta can start at 0, can end at 90. We'll go up in units of 5 degrees, and we can produce our table. We'll have 18 rows in it, and we're looking for what value of theta will make our expression equal to 1. So, okay, going down. Oop. Right, 11, 10, 8, 7, 5, 3, 2. Oh, interesting. Doesn't look like. Here, that's 11, not 1, that's a 10. Okay. Looks like it's impossible. So yes, I will delete this.